Roma Agrawal is an author, structural engineer and MBE. She spent 6 years working on the Shard and designed the foundations and the spire. She is passionate about promoting science and engineering to young people. Roma joins Nikki Gamble in the Reading Corner to discuss her book for young children. How was that built?
I'm really excited to talk to Roma today, having enjoyed immensely her book Built, which was written for adults. Now, you got me from the very beginning of Built, because what came across to me was your absolute passion for what you do. And I'd love to tell our listeners a little bit about where you fell in love with buildings.
I think it was a long journey. So I lived in upstate New York in a little town called Ithaca, which was very, very snowy and quite rural. And then we weren't that far from Manhattan, so we used to take a train or drive down. And it was just such a contrast to, be surrounded by these kind of unending buildings that went all the way up. And I remember how different New York felt to me. So there was this kind of fascination with how different places feel quite different. I was fascinated by the height of the structures that I was seeing. When we moved to India, we lived in a concrete apartment block. So that felt like another sort of contrast again. I became really interested in architecture at that point. So actually, when I was a teenager, I wanted to become an architect. And so this interest with buildings has always been there. And then also just playing with Lego, Meccano, cranes, all these different kinds of blocks that I did with my sister and my parents. I was always interested by the world around me. And I think a lot of people are. And I think, especially as children, we're really, really interested in what's going on around us and asking lots and lots of questions. And I wonder whether that's something that we slowly start to lose the older we get. But I was lucky to have kept this sort of thread running throughout my education, my life.
My dad always taught me when we visited new places to look up. And one of the things that you talk about in your book is how you wanted to be able to see these buildings from all angles. You wanted to be able to look down on them. That's something that's much more accessible to us today, isn't it, with drone photography and filming?
It is. And, you can see such beautiful perspectives when you look at a structure or a building or a bridge from different angles. They're designed to look interesting or different in some way from all sorts of different angles. And I guess the next step is if we can somehow develop X-ray vision, perhaps, and look through our streets and through fields and kind of into the ground to see the incredible amount of infrastructure that actually lies beneath us as well.
You talked there a little bit about playing with Meccano, Lego, the kind of building construction toys. Did you draw as well?
I did. That's such an interesting question. I loved art. I actually took some exams in art in India, which kind of gave me some little qualifications as part of the rest of my education. So I was doing watercolors. I used to do a little bit of acrylics. I used to even do like cross-stitching and bits of crafting and stuff. And I think that having that artistic sort of base or talent, and I mean, who's to say whether you're good or not? It's all subjective, right? It's just whether you enjoy it and sort of have a passion for it. I just think that combination of science and art is so, so vital. And actually drawing is one of the skills that I think may have differentiated me as an engineer when I was practicing and working, because I could always get a pencil or a pen out and sketch up in 2D or even in 3D what my ideas were. And it's such a visual form of communication that a lot of people can relate to. And I think it's incredibly important.
Tell us a little bit more about how a structural engineer and an architect work together.
So the way I describe the structural engineer's job is that it's our job to use maths and physics to make structures safe. So make sure that they're standing, they're stable, and they don't fall on our heads, basically. So that's our job. The architect's job is a kind of broader, bigger vision type of job, as well as a more detailed job. So they kind of encompass the whole thing. So they will have a vision for a building or a bridge, where it should go, the context of that structure within the city or the landscape that it lives in, who's going to use it, how are all the mechanical and water features, going to sort of come in and out, what kind of materials might we use, how will people experience the building, where will the toilets be, down to what kind of texture do we want on our walls? So it's a very kind of all-encompassing vision. And then lots and lots and lots of engineers and designers come in and we work together to basically make that vision real.
So would you say then that the architect's job is more aesthetic? Do you get involved in aesthetics?
So we do get involved in aesthetics, and what we do is so important to the aesthetic. So if, for example, you want to build a big curvy roof, so the architect might be able to say, oh yeah, we want this sort of shape or this geometry, but what we have to do is to make that aesthetic structurally possible. So now we're thinking, should we use steel cables? Should we use a concrete shell? What kind of materials can we use? And we're basically working with the architect to make sure that the aesthetics work. And I think in a more direct comparison, I mean, the viewing gallery of the Shard is a great example. There's 2 levels. If you go to the upper level and you look up, like your dad very wisely told you to do, you can see all of the steel. You can see every bolt, every nut, everything. And we were very involved in the aesthetics of that because we wanted to make sure that the arrangement of the bolts was beautiful and the type of welding we used was beautiful, and all of that looks nice. So there's different ways in which, yes, aesthetic is important in my job as well.
Anyway, you've written 2 books, as I said at the beginning, Built and How Was That Built? I'm really interested to know what the differences were for you in writing the adult book and the children's book.
Built was really like a labor of love. It was my heart and soul. It was everything I knew about my work that I kind of poured into this book. And I found it really difficult to write because writing was not sort of my natural state of being. In many ways, there wasn't a huge amount of difference between writing the 2 books, because when I'm trying to break down principles in the adult book, Built, for anyone to understand, I'm using chocolates, I'm using carrots, I'm using visual examples and little bits and pieces to help grown-ups envision a world that might not be familiar to them. And that translates really beautifully to kids. And at the same time, when I was writing for kids, I don't want to kind of patronize them or use a level that I think is too simple, because kids are so incredibly smart and so observant that there was not a lot of change, to be honest, in the tone or the style of writing. The biggest difference was the number of words. So whereas Built is close to 70,000 words, I think How Was That Built is about a third to a quarter of that. So the ability to pick out the real nub of what you're trying to say, with the fewest words possible, but still tell a full story, I think is what I found extraordinarily challenging for the children's book.
One of the things that I really appreciated about this book was the technical detail, because there are books out there about buildings, but they do tend to focus on the aesthetics or the tallest, the longer, the kind of record-breaking aspect of it. And there's relatively little about how these things are done. And certainly yours is the most detailed that I've come across. And I really love that.
That was really what drove this book. And that's why the title was a question. And I really wanted to basically give children a vision, a picture and an idea of a world that we don't have a lot of deep knowledge about how actually things were built. Who are the people involved? We very rarely hear about the amazing engineers that are actually behind a lot of these sorts of structures.
Everybody knows the name Isambard Kingdom Brunel, but you talk here about somebody called Emily Warren, and this is in the 19th century. And it's a woman engineer.
I don't even think Brunel makes an appearance in my books, actually. He does make a very brief appearance in Built because there's so much written about him. You can find out about him anywhere. So Emily Warren was quite a well-educated woman. She fell in love with a soldier, and the soldier happened to be an engineer and happened to be the son of an illustrious engineer. And basically this father and son duo, John and Washington Roebling, were brought on to design the Brooklyn Bridge, which joins Manhattan and Brooklyn. And unfortunately, John Roebling dies in an accident on site very early on. And then Washington, his son, takes over the project. He becomes disabled due to working conditions, essentially on site. And so just as their family legacy was potentially about to be erased from this project, Emily Roebling steps in and obviously has no degree because women weren't allowed to have degrees then. But she studied cable theory, she studied mathematics, she studied material science. She started off by just transcribing what her husband would tell her to say to other people. But eventually she learned so much that she essentially ran the project for 11 years. And for me to try and picture a woman on a construction site in the 19th century just blows my mind. But yeah, that's what she did.
Wow. Now, what's it like today with women in engineering? Are things improving, or do you still find sometimes that you're the kind of sole woman on the site, as it were?
So, I mean, things are better than Emily Roebling's time. I think the stats at the minute are about between 12 and 15% of engineers in the UK are women. If you move further east to countries in Eastern Europe, it's more like 40%. There are countries in the Middle East and in Asia where it's around sort of between 30 and 45%. So this is quite a UK problem. It's also a slightly US problem, but it's a cultural issue. I have had my struggles. I'm a woman of color, and you can never separate those two things to figure out what the issue is there. But, I feel like in some contexts, in some places, that we're still expected to behave a certain way or succeed in a certain way in order to be taken seriously. And if we try and be any different, then that kind of counts against us. So those are the kind of slightly more complicated things that I think people are trying to now slowly work on and unravel.
I want to talk a little bit about materials. I never thought that I would fall in love with concrete, but yes, reading your book made me find a new appreciation for it. Now, concrete is one of those things that I remember when the National Theatre was built in London, and I remember when the Barbican was built, and they looked really lovely when they were new. And now they kind of look dirty, and I think it doesn't wear very well.
I mean, I actually think it wears well. Like, I like the aged look of concrete. So I guess it depends what sort of feel and look you like. I think concrete is an absolutely incredible material. It's very strong, it's very robust, it's very long lasting. You can put it in the ground, you can put it underwater. It's enabled the incredible structures that we have built. It's very ubiquitous, so countries all over the world use it. And of course, we now have to really start very seriously thinking about its sustainability angle. And it's the second most used substance on Earth after water. And so for that, yes, I have a lot of admiration for concrete. And I guess my wish is just that as we move towards the future, that we learn to use it in the most sensitive and ecological way possible.
Are we developing new materials? Is technology allowing us to develop materials that are going to lead to different kinds of buildings?
I love that question because I always say how, bricks have been around for 10,000 years. Concrete's been around for thousands of years. Steel and metals have been around for thousands of years. So what is it actually, what's the revolutionary new material that we're going to be building stuff out of? People are talking about things like carbon fibers, for example. So carbon in different forms could be one. So graphene is an example of very strong and light material, but we haven't quite yet been able to translate that into large scale structures. On the flip side, we're also seeing a sort of return to more traditional materials like stone and timber and more indigenous ways of building because they're inherently more sustainable. So it's a very interesting thing to me where I think moving forward, we're going to be looking to our past and looking at kind of more futuristic materials, and probably some kind of mixture of the two is where we're going.
That's something else that came across in your book, sort of looking at ancient civilizations and having that appreciation for exactly what they were able to achieve. Maybe pick one of those to tell us about.
Let me pick the Qanat system in Persia. So this was a system of wells that the ancient Persians dug, and they still use today. They still maintain and use them today. It's an arid land. It's a desert. Water's hard to come by. So there's an understanding of geography that aquifers, hold waters, layers of stone hold water deep underground. And then by digging a series of wells and then a tunnel at the bottom to join the wells up, they were able to tap into the aquifers and extract water. And I always think that that's such a great example of good engineering where something that you do endures. So this is a technique that's been used for a couple of thousands of years, and it's still being used today in particular places. It's sustainable in the sense that you're using the natural resource that's available. It's maintainable, so it's something that you can use for a really long time. And I think we have so much to learn from that in terms of understanding our land and responding to that and treating it with respect.
When you're talking about how things work in this way, you can do so much with words, but sooner or later you need to show something physical. And in a book, that's illustration. How did you work with the illustrator to convey some of these mechanisms?
So, I mean, Katie Hickey is an incredibly talented artist, and her father happens to be an engineer. So she sort of grew up with an understanding and appreciation for what engineering is. And she can portray really complicated things in a really beautiful way, but in also a really playful way. And that's what we wanted. We wanted to make these complicated technical pieces of information fun and exciting. So I remember just dumping a whole load of photographs and articles and a few of my own terrible sketches and papers and all sorts of stuff on her, which she just kind of absorbed and looked at and did tons of research on, and then basically created this book. And she often talks about the fact that a lot of buildings, they're quite monochrome, so they might be made of red brick or they might be glass. And one of the biggest challenges she talks about is kind of bringing life to those buildings, which I think she's done an extraordinary job of.
Let's talk about some of the types of building that are in this book. It's structured around things like building tall and building long. I have a fascination with bridges. Tell us about some of the fascinating bridges that you've looked at.
One of my favorite bridges, I think, from the book is the Te Matau a Pohe, and apologies for my pronunciation, which is this incredible bridge in New Zealand and one of the Northern Islands. And it's a very busy river. There's a lot of traffic coming up and down that river. So it was important that whatever bridge was installed could move. At the same time, there's a very rich Indigenous history and culture there. And so the designers, the architects, the engineers wanted to make sure that they were paying respect to all of that while making a really high-tech movable bridge. And so they used the inspiration of the demigod Maui from the local culture, and the fish hook that Maui used, as the story goes, to pull up the fish from the water that turned into the island of New Zealand. And I love how they used this beautiful story and this rich culture and then created this bridge, which is technically so clever. So it basically kind of rocks around the hook part of the fish hook to allow boats and ships to pass underneath it. And it's just such a lovely bridge. It's designed in an earthquake zone. So that was one of the very big technical challenges they had. It moves, as I mentioned. It needs to be opened and closed pretty frequently. And at the same time, it received a blessing from the local iwi or the Maori tribes when, construction started. So I really loved that bringing together of community and amazing engineering.
You mentioned earthquakes there. Obviously, the world is changing. We are experiencing more and more extreme weather. What does that mean for buildings?
It means two things. One is we need to think very carefully before we even start building something, why we need to build that, and what is the best way of actually building that? What is the best material to use? And is there some other way that we can achieve what we need to achieve? And then while we're doing the actual design and construction, we need to be thinking about future-proofing. We need to be thinking about the environment, the materials that we're using, but also, if rainfall is going to increase or flooding might increase or temperature profiles might change, then our building needs to be able to withstand those things.
We tend to think of people like yourselves and architects designing and putting up these buildings and then walking away. But it seems to me that buildings must need some kind of monitoring.
I would say in most cases, what you said is probably about right, that we sort of finish a project and we're done. And then it's left to the owners of the building to look after it. And then sometimes, yes, you could get a phone call saying, oh, we want to change in there, or something not quite working for us, or whatever that might look like. But yes, I think that it is something that we should be thinking about and doing more of. So there are new pieces of technology that are being developed, for example, putting fiber optic cables into the foundations of structures, which then have like gauges or the ability to take measurements to see, like, are the foundations being loaded as much as we actually think they are? You know, is the building moving as much as we predicted it is? And then, you know, there are researchers at universities who then can collect that data and then start to inform how we actually design. So I think there's a very interesting sort of two-way process there. So I'd like to see sort of more monitoring of buildings.
Interesting. Now, I suspect that you're a very particular kind of tourist, and whenever you go away, I'm sure you go looking for buildings. That comes through a little bit in Built as well. So what have you been most fascinated by on your travels?
So you're quite right that I'm a particular kind of tourist. And my husband always complains when we get back from holiday that there are more pictures of like bricks and arches than there are of him. So, you know, there's definitely that. You know, I really, really, really love Rome. So the Pantheon is definitely one of my favorite structures in the world. So I've been there twice. I just love it because it's so, so beautiful. And the technical aspects are also so brilliant. So it's a perfect dome on the inside, but then the outside is not. It's a much flatter dome, which means that the base of the dome is thicker in terms of material than the top. They had to do that because they understood the type of forces that would be channeling themselves around this dome. And they used concrete. And the Roman formula for concrete is really not that different than what we use today. Of course, we've refined it and so on. The biggest difference is that in the concrete we use today, we tend to put steel bars inside to create this mesh which binds it all together. The Romans didn't do that. So they've created this immense dome with no steel reinforcement inside it. And it's still standing 2,000 years later.
I'd like to know what you're working on now.
So I've done one of those funny things where after swearing never to write another book after Built, I am now a writer full time. So I've taken a little pause on my engineering career at the minute, and I am writing my next book, which is called Nuts and Bolts. And that's about 7 small pieces of engineering that changed the world. Wow. So this kind of covers all forms of engineering. And while I'm doing some shows for radio and presenting and other media engagements and mentorships and so on. So that's what I'm doing for the moment. I mean, it seemed like a good time during the pandemic to maybe take stock and try something different. So that's what I did.
Yeah, I'm definitely going to be reading that book because, as you can see, you've kind of fired me up with new enthusiasm for building. What about young people who are going to be reading this book? Some of them may also be fired up and, you know, not be as old as me, so they've got an opportunity to make a career path for themselves here. What's your advice to them?
Yeah, my advice to them is to have the confidence in themselves to go for it, and also to do research, because I think, you know, there are all these stereotypes that persist about engineering. Many of them might be reasonably accurate, but a lot of them aren't anymore. Things are changing. There are people from all sorts of different backgrounds starting to come into engineering. I hope I've reflected that in the engineers gallery that I've got at the back of the book. I've tried to make sure that the engineers I've represented are from a big range of backgrounds. And so I really want to see engineering becoming a more and more inclusive and diverse space. And I would encourage the young generation of today to be a part of that.
Roma, it's been an absolute delight and an education to talk to you today. Thank you so much for joining me in the Reading Corner.
I really appreciate you having me. Thanks so much.
In the Reading Corner is presented by Nikki Gamble and produced by Alison Hughes. If you have enjoyed this podcast, please leave us a review. If you would like to find out about other events and courses, visit justimagine.co.uk. Join us again in the Reading Corner on your favourite podcast platform.